Hello, I'm Angel Feliz, and this is Data Science Learning Community. We are exploring the Chapter 11 of Outstanding User Interface with Shiny, and we are going to have a better sense of how R and JavaScript communicate each other. And the purpose of this chapter is to explain the mechanisms behind the scenes, how Shiny responds to for driving R Shiny communication. The crucial is you and developing your very own Shiny widgets. We are not going to do it right now, but they say that it's important to understand in order to do it. And the first thing we need to know is that even though for APIs and basically for REST APIs, we use HTTP, but it have limitation. Because every time you send a message, the connection is closed and you need to open and get from each message. Every time you make a click or hang over, in Shiny, it will need to send some message to the server, and that take too much time. So we need a permanent connection. So it allows the bidirectional fluences between R and JavaScript, and that's called a WebSocket. And they start with this simple example, just a button and a slicer. When you click the button, it sends a message from the client. So you are the client right now, you are using your browser. From the browser to the R server that uses R. So a communication between JavaScript and R. Then when you click over that button, it triggers an outside event function that processes the message and updates the alt server. And then it also fires a update slide input, because at the end you want to, from the bottom, to change the slicer. Send a message back to the client containing the ID and the input to date. And as the slicer now, JavaScript receives the message and update the corresponding input element. So it changes. And of course, it need to check, as this is an input element, it will take that value back to the server, even though in this application doesn't have any purpose. So if we see the diagram, we see that, okay, we click over. That click will send a message to the server. You see the message here. Here we see just after a message is the observe event. It will update, the app, we trigger basically the update slicer. And with the slicer, also we need to send a message. Okay, I know that I need to date this value in the slicer. So the user need to see it. So it sends another message. And in the client side, it may do date, change the UI and show the value here in the input slicer. So you see, it's a back and forth, even for simple operations. How they communicate if they are so different? The most important element is the JSON file. It looks just as an object in JavaScript, so you have like a list, in the way they do it. And we can see this example. We have the attribute name, color, planet, and also even as a data frame or a nested list, depending on how you place the cool brackets or not. Or not. And in R, we have several tools. Not this, just explain this one, but I remember to see another that was even faster. So they have competence of how can you write and receive JSON faster. But we have this option, the JSON Lite, and you can read any text from the JSON and have the response, and it just take it into a list. And you see that this part is a data frame. If you don't want to have the inner part in a data frame, you can simplify vector force and it will show as a list. It depends on how are you going to use the output. In this case, to me, yeah, it makes more sense to have it in this way, because in this data frame, just one row, one row, you don't want to have it managed in that way. But yeah, you have the alternative. And also you can export JSON. So you write a list and you just pass to JSON, and it will just write in this way. Even though it's just one line, it's a JSON, just that it's not pretty. If you want to see it better, you can add also these options like on bots and pretty. So pretty will make sure to have the margin, so it looks like a JavaScript object. And on bots, remove the curly brackets in that part. They say, I was reading the documentation of this function, and they say they have on bots function, and you can apply, I don't know how, but they say rather than using this option, there's a safer way to do it. And also JavaScript is JavaScript object, so they can parse, so they can read, and they can also export the JSON easy. So that's the format we are using for communicate between the two languages. So what's a WebSocket? A WebSocket is a computer communication protocol providing a simultaneous two-way communication channel over a single transition control protocol connection. So yeah, basically it's a different protocol. You are not using HTTP. So you just start with HTTP and then you switch to this protocol, that it would be faster and will keep the connection open. And yeah, for creating that WebSocket, in R we have the HTTP UV package. That's the package that enables us to be a web server, even though it's HTTP or WebSocket. What does he need to start a server? Right? It needs a host. This is the IP for localhost connection. So, and this is just a port that is not default for any application. We can use this one, and you provide this information. These functions that are in this list, it's not only that you need to invent yourself, they are in that if you just read the documentation, you will see them. So they are like a standard function that they expect to see here. So WebSocket connection open, you will start creating or defining a WebSocket object, and you use a cat. Server connection is open. So in this case, this message will appear in the server when it starts. When a client starts, you will see that in the console. Once they receive a message, what they can do, they can also bring in the console, hey, server receive message, and just place the message as part of the part, and also send a message to the client. And also you can define the behavior when you are closing the server. We can see that. Let me just can you see my terminal? Imagine, yes.
I can see it.
Okay, so I'm running R via Docker, so I will just access to that Docker file, and I will run that server side here. Oh, I'm thinking of forgetting something. Yeah, it's the same example here. What I don't remember, yeah, the code to talk to the server is also here in this summary. Yeah, here's the for creating the client. So, and we also have this slide. Let me just move this. Yeah, the next slide. And also we can define using R the web a web client. of course, your browser is our client, but for this example, we can use the WebSocket package to start the connection in the same port, the same host also. And we can send that using our programmatic. Now that we have both, we can go to the example. It's not working as expected, sorry. Okay, just move this. Docker, Excel, PI, Studio is a studio is my container. So I just ask for bash. And my project is at home, studio, book club, samples, chapter 11. Yeah. Now we can run R. I have R here. We can source the sample one. And we run S. We can see that the server is running. So also you also have the method S is running. And you can see, yes, it's running. Now we can go here to our studio and run this part. So we are start using the same connection to the same host and port. And now we can send a message. And here we can see, we don't see nothing here, but if we go to the terminal, we can see that connection is open. You know, you don't see it in the client side, but you see it here. And now, once you send the message, the client receives the message from the client, and the server receives the hello server. And now I can close the connection in the client. The service is still running, so I need to close the connection here as closed. Just close. Yeah, it's running. Well, it's a stop. Stop. Yeah, the method is a stop. Yeah, it's not running anymore.
Really nice example. I didn't completely understand it in the chapter, but now I do. Thanks.
Yeah. Yeah, the point that I was running in the same session here, and I was getting the message that was part of the server. So I
Mm,
just you make sure that when you see cap here, you won't see in the client side. It just
mm,
happening in the server side. That's
right.
why it's clear here in the console. Let me just quit R here and exit for the container. And exit for the I won't close this. Okay, whatever. Yep. We saw here how we can match and how the message will transfer, and how every part was working as expected. And here is the diagram of what we saw. So we have the client that was the WebSocket package that was after starting the connection, send the message, the server process, and send back a response. And here you see that this is a bot, and one server can manage many clients. And that's the point. That's the main difference. So what happened when we start a connection? The client sends a HTTP request known as a handshake, and the server accepts the HTTP code with HTTP code 101, meaning to switch the protocol from HTTP to WS or WSS for secure connection. Because right now we are not using, any secure connection. We are just using the local one. Okay, so what do we need really to create an app? Just of course, using R as a web server, we need first to define a host. In all the examples in the book, they use this. This is localhost. But I'm using Docker, so I was having problem with that. So if you are using Docker as me, you need to use this 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 IP. That's the default for Docker, and then we can map that. In our case, you need to define a port that is free, no used by another application. Then you need to define a call function. That's the response that you will receive, that you will give to the user. So when they start the connection, what they will receive at first time. That's what you place in code. And on what's open and on what's open, then you will have all the logic, that is related to your server. So let's see it by part. In this example, we are defining the function of the response. Basically, it's just a list saying these three parts. So here we have the status. 200 is okay. So, you are allowing the connection. You are defining what kind of content have your body. In this case, we are using test HTML. And the body, you will place the HTML. So, for sure, they didn't place here. Well, that's the three parts. You place the code, status, the type of content that can be an image, can be raw data, and the body that have the data. And also the server function. And in this case, we are going to have a more complex example here. They start the connection with the cat in the server side. When they receive some message from the user, we are going to get the JSON and use the number because it's a slicer. So the input that we will receive, it comes from a slicer, and we are going to use the normal distribution with that value and display a histogram. It will only take place that in the server. So we are creating a histogram, but that, is not sending nothing to the user. And also, after making that histogram, he's going to sample one number by random from 0 to 100. And you will see, and then you pass that value to some widget, So we are having the response in JSON and sending the response and just cutting the response just to see the response in our console. And yeah, also we just place a message for say, hey, bye bye. And here is the whole call, the complete call that we need to make to display the app. So I will go to run it. This time I will do it just in our studio. So I will just run this function. No, this one. This is in the package of the book, but I cannot do it because they don't have an option for changing the host. And also, yeah, here I'm using the placeholder of Spring. Yeah, you showed me it's really helpful to have the port here. And now, yeah, I can define the function and run my app and confirm that the app is running. As you know, we have a whole body with HTML. If I go to localhost 8080, we have the app. It's not a Shiny app, it's just a normal app using JavaScript directly. So we need to place this side by side with our studio. Let me just, I can do it. This mouse is not working well. So let me try to do it this way. Great. And our studio in design. Okay, great. Now, when I start here, in my user interface, if I change the slicer, you see the histogram is taking, but in the server, because this part is the server side. And the garbage is changing the color based on some a random variable. The value, this value part is updated just based on the JavaScript code. So yeah, this value is not passing by R. They are not using it. Well, that's the basic use of this app. Let's see what do we have in the JavaScript code here. We have in the body, that's the part that we saw, the range that was, the part that was moving around 0-100, and the label that was showing how much was the value. So this field will be filled by JavaScript. Right now it's just empty at the beginning. And then we have the garbage that will be getting the values from the sample part. If we see here how is the JavaScript code, they start with the document content loader. So make sure that all your HTML is loaded before running any method. They get the garbage. They get they make the connection using the WebSocket package in JavaScript. They on open, they do nothing. And then when they receive the message, they get the data and because this part comes from R. So that's how they receive. They just define the on message function and just get the data, because you know that in JavaScript the point is like the $sign. Define the variable and get the variable to update the part. And also, this is the code that updates the value part. So all is taking place here. So they get from the ID, they have the label, and they take the slicer value from the ID, and they just paste them together. So this is the part that is managing that change. What else? And yeah, this is the on input. They are also sending the value of the slicer. So R can make the plot, the histogram. They are parsing to integer because by default everything that you receive in the web page is in test. So they need to make sure that it's an integer to pass that to R directly. And yeah, that's basically the code we saw. They also have a section here in the book. Once we understand that part, they say that the session object that we have in the shiny function is from the class shiny session R6 class. And they say that session have two important methods for us. Send customer message allow us to send the same message we saw in this chapter. So if you see, and you can write your own JavaScript or any widget, so you can talk directly using JSON to your JavaScript code, and have made something that not might be the default behavior of Shiny, and that's very important. And also you have send input message that is maybe related to the update function we have in Shiny. And maybe that's when you want to make updates and input that maybe are not the normal ones or the ones that are already defined in Shiny. I don't know maybe why this method is so important, but he explained it here in the chapter. I didn't understand really this part, just explaining how the connection started. Uh, but we can see here now we understand how we can also debug a Shiny app based on this knowledge. We can, let me just close this. We can run Sunshine. I think I need to close this app also. App close. No, stop. Stop. Yeah, service close. uh, Now we can debug a Shiny app based on this knowledge. And basically, it's important if you are having some problems with your Shiny app to understand what is the problem coming from. Like, oh, it's a problem in my server side, it's a problem in my JavaScript code, it's a problem in the connection between those two. So we have the network, and I need to reload. And now we here have the WebSocket. We see the data. We see, for example, that it sends this variable, the variable C cylinders, and it have some responses, but the most important one and the one that we see is the table, and we can see a long response, with all the data in the format. And every time we change, we send the message and receive the response. Every time we change the variable, we send another message and receive the response. That's the table. Another part that I don't really understand yet, but this is the table that we see. And that's basically the chapter, to understand how it communicates, how you can get and see the messages, how all this is JSON, we saw before, and it's represented the same way here. And yeah, that was most introduction chapter, but I hope it helped you to understand and introduce to this word.
A really nice presentation. I did not understand the WebSocket connection very well from the diagrams, but the way you explained it now, I think I get it better now. Um,
Great.
and I remember one example where there was a JavaScript library that has where you if you write something using your pen on a tablet, then it converts it into text. So it is available in the browsers also. I'll try to find it and then share the link. So you can do it on your computer or on your tablet. So if you write it, it will convert it into text, and it's all using JavaScript. And I was trying to make it useful in the Shiny app, so that in the app, if someone writes something, then it's automatically converted into text, and then that is sent through the text input.
Well, you
So
mean that is a OCR like that? Like you write, normal letters and it would just compile that way?
yeah, I'll see. I'll try to find it. I actually was successful in making the app. It wasn't very good at the UI part, but
Mm-hmm.
using ChatGPT, I was able to do that. And now looking at those functions, send input message and send custom message, that's what it was using. So I think it would be a nice example. I'll try to find it.
Yeah, great. Great, great.
I think next chapter is relevant to those two methods. I think that's where we can probably discuss that example.
Yeah, perfect. I don't remember. I'm presenting next week. So I
Um,
will stop. I will stop this call now. So we complete the chapter.